The setup menu is segmented into three areas. The first being spectral processing. The second area is specialized data capture and icon action selections. The third area is general system information setup. Setup for the system parameters in this first section depend on the type of application that is being set up for. For example, if we are setting up for measuring absorption or transmittance, the detector integration time must be set up to allow the reference to be maximized without saturating. The number of scans to be averaged is usually set to a high number because the square root of the number of samples you're averaging improves the signal to noise by that number. Spectral smoothing controls are used to create a data set with small variations when the smoothing is increased to a high level. For example, this is typical in color measurement, where a 10 to 20 nanometer spectral resolution is all that is required. Pixel boxcar is the most effective type of smoothing. It is found in the status panel with the letters SM. Savitsky-Golay is used to smooth spectral data without crushing peaks. Display persistence is used to prevent bouncing of digital data in certain types of readouts. Average dark baseline should only be turned off when long detector integration times are expected or needed. Temperature compensation is a specialized algorithm used by StellarNet to stabilize the spectral baseline. It is updated every 15 seconds and eliminates the need for thermoelectric cooling of the detector array for most applications. Use X-timing resolution control level 3 for the highest possible spectral resolution. Episodic data capture allows us to capture full spectral data over time in any mode. Using the File Open function, a user can graph an episodic data capture in 3D. A utility is provided to extract this data to be read in by an Excel spreadsheet. The optical trigger capture allows a user to specify a relative or absolute magnitude for trigger at a specific wavelength, or to choose any wavelength. Additionally, the trigger can be specified to repeat continuously or to trigger stop after a certain number of transactions have qualified. The result of the optical trigger capture can be fed into the episodic data capture, providing a solution to a variety of applications needing specialized data capture. External trigger capture is used in conjunction with the hardware trigger input on the spectrometer, where a jack is placed on the rear panel. The external event signals the spectrometer hardware when to capture the spectra. As in the other data capture functions, up to 8 spectrometers can capture simultaneously. The spectrometer channel enable function for drift correct reference is an important function and is used when measuring absorption, transmission, or reflectance to correct any drift in the light source. There are two ways it can be enabled. In the first way, we only have one spectrometer channel, and we elect a wavelength that does not absorb or has no loss at this particular wavelength. With this drift correct processing type, there are two choices, either a delta from a base reference or absolute as a zero reference. The other type of drift correct reference would have a second channel devoted to looking just at the light source and making the compensation on the primary channel. In this case, just nominate the channel number that is being used as the drift correct reference. Map logical to physical for spectrometer channel enable is available only when these spectrometers are daisy-chained together using the parallel port. Action for peak area icon is a control used for the green peak icon seen on the toolbar. Auto Find Peak allows clicking on the toolbar icon to automatically seek a peak before it starts the computation for the centroid and area. Turning on the continuous function allows it to continuously repeat even though you are not selecting the icon on the toolbar. This may be useful when measuring tunable lasers or other types emissions that might shift or increase in size. Display refresh and slide bar allow you to set up how often the display is updated and how long an integration time you would like when you move the slide bar on the toolbar all the way to the right. Channel display trace colors do just that. Let's change the color to red on the current display trace. Graph print information prompts allow the user to set up specialized question and answers that will be printed out. Interface port and detector must be set up when initially configuring your system for your interface type and your detector type. Unit calibration coefficients must be set up when you first get your system. The calibration coefficients are found on the label on the bottom of each spectrometer. There's 3 numbers. Let's step through this to see what we need to enter. First, it asks us for a unit number, Unit 1. Then C1 coefficient, C2 coefficient, C3 coefficient. And then what the physical address. It's usually the same as the unit number 1. If I was inputting the information for channel 2, the first number would have been 2, and then this last number would have been 2. The warning message can be enabled or disabled from the setup menu. This is convenient for people who are not familiar with spectroscopy. Every time you change one of the parameters in the system, such as detector integration time, the number of scans you're averaging, spectral smoothing controls, temperature compensation, X-timing resolution, you'll have to change the configuration for the dark and the reference. In other words, you have to retake a dark and retake your reference.